Welcome to October's Leetcode Challenge. This problem is called Stone Game 4, and it's a little late, but better late than never, right? Alice and Bob take turns playing a game with Alice starting first. Initially, there are n stones. On each player's turn, that player makes a move consisting of removing any non-zero square number of stones in that pile. So either 1 stone, 4 stones, 9 stones, 16 stones, so on and so forth. So if the player cannot make a move, he or she loses the game. Now, given a positive integer, n, return true if Alice wins the game, and she's the one that starts the game. So they give you a couple examples here. Now, in order to solve this, we're going to have to go with a DP solution. There are ways to do it recursively and using memoization, but I think the DP solution is a lot more straightforward. So let me go to the whiteboard and explain what's going to happen. So say that we have a DP array and we want to figure out what's going to be the state of the game for a couple stones. We'll say 1, 2, 3, 4, 5, right? Now, initially we can set everything as false, all right? We'll set all these as false at first. And what we're going to do is start at the very first stone number and check to see, given our choices, can we get to a state of false? So what I mean by that is if we have 0 stones, we know that you've lost, right? If you've given a state of 0 stones, that means you've already lost the game. So say that we start with 1 stone. Now what choices can we make? Well, we can only remove 1 stone at that point, right? So if we remove 1 stone, we can see that we're going to go to a state of false. That means Bob has lost the game, right? So it's kind of like it flip-flops here. If we see that, hey, we can find a false position, then we're going to make this turn to true. Now, what about at 2 stones? Well, at 2 stones, the only choice we can do is remove 1 stone. And here we can see that at that state, it's still going to remain true. So Bob can win this game. Well, that means that we can't win here, right? We can only move 1 stone, and that's going to make Bob be in a winning state there. So that means that we're going to lose. So this is going to have to stay a false. Now, what about at, I'm just going to delete all these. What about at 3 stones? Well, at 3 stones, we know that we can only remove 1, but we can put that state into a false state, so this is true. Now, what about 4? Well, at 4, we can either remove 1 stone or we can move 4 stones, right? So if we remove 1 stone, that means Bob's going to win. But if we remove 4 stones, that means we can get to the false state immediately. So that is also going to be a true. Now, what about 5? Well, at 5, we go back. If we only remove 1 stone, it's going to be true, so we can't win there. And if we move 4 stones, that's all still going to remain true. So this is going to remain a false here. And this continues however infinitum, right? We can just build up our DP array, and at that very last position, like say we have like 33 stones, whatever this is, true or false, that's going to be the answer. So hopefully that explained it decently well. Let's go ahead and start coding this out. So we're going to start out by creating a DP array, and initially everything is going to be false, and we'll say for blank in range of n, but we need a +1 here to also include the 0 index. Okay, so first things first, DP0 is already false, so we don't need to worry about that. We'll say for I in range of 1, we'll start with 1 stone, all the way to, let's see, n plus 1, right? And now we're going to, these are the number of stones for our DP array, and we're going to decide, hey, how many choices do we have here? And there have to be a square number there. So what I'm going to do is we'll call this, I guess, j, and we'll start with 1, and we'll say, look, while j times j, the square, is less or equal to the I, we will check if dp of I minus j times j, which is the number of steps we've taken, if it equals false. So I guess we can just say if not. Then we know that we can put Bob into a state of false, right? So that means this dpi should equal true. And really, we can just break the loop there once that happens. Let's see. Otherwise, we want to continue and say, okay, make j plus equal to 1. And we'll check to see however many stones we can remove. And this is going to be like at first 1, then 4, then 9, then 16, so on and so forth. So once we finished that, we should have our dp array here. We can just return dp of -1. So let's see if this is working. This equals true. What about 5? 5 should equal false, and it does. Okay, let's go and submit that. And there we go, accepted. So great. That's pretty easy, right? There's definitely ways you can do this recursively. I think I saw something with an LRU cache, but I didn't want to go through that because I think this is much more basic and understandable. As far as time complexity, it's going to be n times square root of n, right? So n times the square root of n, I believe. Yep, okay. So that's it. Thanks for watching my channel, and remember, do not trust me, I know nothing.